Welcome to class. Today we are going to discuss about the tangents and secants to a circle. Here we are having tangents, secants and circle. Everyone knows about the circle. We learned in the earlier classes. And we need to know about the tangents and secants. So tangents, it is a Danish mathematician introduced this tangents. Tangent means to touch. Secants means intersecting. So here we are going to know about the tangents and secants. Here how can we take the tangents and secants to the circle? Everyone knows circle is a closed figure, but how much it is right? So okay, it is a good closed figure. If we are taking, before going to know about the some basics, how much a circle is a closed, so whether it is right or wrong. So basically circle is a closed figure. Okay, but if we are taking here one figure, here one figure, so these two figures are also closed. There is no gap in between the line segments. So how can we say this is a triangle? How can we say this is a quadrilateral? Everyone knows about the polygons, so no need to describe here. So I am saying circle is simply not a closed figure. It is a closed figure, but the circle is combination of points from a fixed distance from the fixed point. Then it is called a circle. So fixed point and fixed distance. Then it is a circle. Okay, how can we say this fixed point means whenever we are taking one point, this is the fixed point for the circle, and fixed distance I am saying the distance as some line segment or convenient. Whenever we are drawing using the compass, we are forming one circle. It is the fixed point for the circle, and whenever we are taking, the distance should be in all areas within the circle be equal. Then these distances are called radii. So single word, it is the plural, and radius we are saying. This is the radius. These are denoted with the smaller, and center point always we are saying this is the O. So from the fixed point to the fixed distance, then it is called, then it is forming combining of the all points, then it is a circle. So in circle we are having number of parts like radius, we are saying radius, diameter. So diameter is denoted with D and radius with R we are saying. So always diameter should be 2 times of the radius. How can we define the diameter? Before going to know about the diameter, whenever we are drawing in circle one line segment that should be touches the points on the circle, it is a chord. It is a chord. How can we define this chord? Means here we are saying it is a center point O and AB is the chord we can see, but the longest chord is denoted as the diameter. Why should we say that is the longest chord? Means it is going through the center of the circle. Then we can say PQ is a diameter. In this manner we can derive the diameter, radius and chord. So based on these topics we need to know about the tangents and secants. First we want to know tangent. The word tangent. A line touches on a point of circle. It is called tangent. So how can we take the tangent? Here this is the center of the circle. Then when we are drawing this line L touches in one point, then it is a tangent. So it is touching the circle at a point, only in one point only it will touches. Then it is called tangent. Coming to the next word, secant. So here we know to about the secant, a line intersecting a circle in two distinct points, then it is called secant. How can we take this? Here this is the center O, and already we know whenever we are taking one line that is touching the 2 points on a circle, it is a chord, but I am taking here, this is the line L, it is touching the circle in two distinct points A and B, then it is called secant of the circle. Now we want to know about the radius of the tangent relation. If we are having radius and tangent to a circle, the radius should be perpendicularly bisecting the tangent with a 90 degrees angle. That is the meaning we are having. So it will forms 90 degrees angle. How it is possible? See, this is the circle we are having. This is the center point. I am taking one tangent here. So it is touching at a point A. This is the line L. So whenever we are taking a line segment from the center point to the circle, it is called radius. Then it is forming a touching point 90 degrees angle. This is the meaning we are having. It is the 90 degrees. Now I will construct a tangent to a circle. How can we construct a tangent to circle? Here I am showing by using the compass and ruler. So here we does not want any radius to construct a circle. If we are having measurement, you can go through the procedure only. So I am drawing here one circle using convenient radius. Here I draw one circle here. This is the center of the circle. We are taking this one as O, and I am taking one point on circle as P. I am taking center as O and one point on circle as P. Now I am joining this. The radius is formed OP. Now P as center, I am drawing two arcs. Why? To get a tangent to the circle. Tangent is nothing but it will touches the circle in a point, and the radius must be forming 90 degrees. To show that, I am showing that construction here. So I am taking here the P as center by our convenience. So here you should take the more than 50% of the radius and draw one arc here. So here I am taking arc here. I want to extend this one by using dotted lines. So the arc touching the extended line, the dotted line in a particular place. Then from that point I am using with the same radius and I am drawing one more arc. It will touches the previous arc. Again I am taking the same radius where the arc touches the previous arc. That is a center point. And one more arc I am drawing. The second arc also touching the first arc, which one we drawn from the center P. So we know if you are drawing here means to get the 90 degrees. How? So if you are taking it is a line segment from the angle center point to here, it is the 60 degrees, and from here to here is 120 degrees. Then we will get by bisecting the two arcs distance, then we will get the 90 degrees angle with the same radius. Now take the point that one as some A or X, B, that is your choice. Now I am joining the intersecting point through the center. Then I am drawing the line here. Then it is the line L, and it is the having 90 degrees at P. So this is called tangent. Line L is the tangent of the circle. In this manner we are constructing the tangent to a circle with the given measurements or without given measurements also. So this is the condition we are having. The radius should be perpendicular to the tangent. Then only it is the right and consistently perfect. Then I am giving some steps. How should we write the steps? So in constructions anyway, we does not think about the steps. How we are constructing using the ruler, scale, compass, whatever we are having the measurements. That is the mandatory accurate value we are having in the construction. We will not think about the steps. How we are constructing that particular diagram. We should write minimum 5 to 6 points. Then we'll get the accurate marks. See, first step I am taking here. Draw a circle with your convenient. And second point, take center as O and a point P on circle. Now the third point, extend OP by joining and draw arcs P as center. And the next point, to get 90 degrees angle, bisects the arcs to get angle at P. Next point, join point A to touch the point P and forming 90 degrees at OP segment. And OP is perpendicular to L line. So these are the steps we are following. Our next topic is segments of a circle formed by a secant. So we know in a circle we are taking the region bounded by arc and the chord, that is called major segment and minor segment. If the segment having small, this is called minor segment. If the circle having same segment, here we are taking AB, here also I am taking AB. The part which one we are having the more in the circle, that is called major. In this manner we are having the secants. Already we know about the secant. That secant should be intersecting the circle in two distinct points. Here AB, and this is called the minor segment, and we are having here one more circle. Then we are taking L line, here AB intersecting points. This is called the major segment. Then it is the secant, we can say. This is the only chord. This is the chord. This is the secant. This is the secant we are having. So chord is in between the circle that touches the 2 points on circle, but the secant intersecting the circle in 2 distinct points. This is the way we can show the secants in a segments. Now we are having one more point here. Number of tangents to a circle from a external point point. If we are having one external point to the circle, how many tangents we can construct? So here I am showing here. First draw a circle with your convenient radius. I am drawing here a circle with my convenient radius, and I am taking the center as O, and one more point I am taking outside of the circle. So I am taking here, it is a P, and now I am joining these 2 points. Now I got a line segment OP. One point is inside of the circle, one point is outside of this circle. So how can we construct a tangent? Okay, so I'm taking from P onwards more than 50% to bisect the OP to get a one more circle. So why? Because I'm forming that means to get a tangents using the outside or external point. I'm drawing one arc by taking more than 50%. One arc here and one more arc here downwards, and upwards we are having 2 arcs, and O as center. Again I'm drawing the arc here, and the 2 arcs should be intersected or coincide one way. Here I'm taking the point as some X and Y, the intersecting points. Now I am joining these 2 points X and Y's. These 2 points, after joining, I am having the length here should be equal here. So I am taking the point as that intersecting point as M. Now using that I am drawing circle. See, from here to here distance, how much we are having? From here to here also same distance I am having. So now I am joining that, then I am forming one circle here. Now I want to join the point, intersecting point to the O. Then the intersecting point of 2 circles I am taking here as A and here as B. Now I am joining the point A to O, and one more point I am joining here O to B. I am joining here O to B and O to A. I joined here. Where the point we are having A and B, I am drawing line from A to P. A to P I am drawing here, and the line touches the point A, and again I am drawing here one more line from P to B, right? So I am having these 2 lines. I am taking this one as L, I am taking this one as M. So here I am having L and M 2 lines that are called, it is the tangent and it is also a tangent. So here I have 2 tangents having from the external point. In this manner we can construct the number of tangents to a circle from a external point, means we are having only 2 tangents. This is the way we can construct the tangents. And one point we need to check here, the intersecting point where the tangent touches the circle, that radius should be having 90 degrees. We need to check out. So I will show you whether we got a 90-degree angle or not in that particular point. See, I am showing here. Then I am keeping the midpoint of the protractor and the intersecting point of the circles and the tangents, and showing the baseline on the particular tangent. Then from here to here we are having the 90 degrees. Then our construction is perfect, 100%. You will get the full marks in the construction of the tangents using the compass and protractor and ruler from the point external. So this is the way we can construct the number of tangents to a circle. and I am having one more topic. So how I said to write the steps, how I constructed, that only we are writing the steps in a statemental formation by using the verbal forms. So one more topic we are having here, finding length of a tangent. How can we find a length of the tangent? Here I will tell you. So I am drawing here one circle, right? It is the center point I am taking, and I am taking here, this is the tangent I am having here. The intersecting point is P, and I am taking center as O. I am joining the P and O, and this is the radius we are having, and I am joining Q and O. I am taking one point Q on line L. So here we are having the triangle shape POQ, and always we know that OQ is greater than OP. Here we are having, this is the condition, and OP is perpendicular to L line, or OP is perpendicular to PQ. Also we can take from here to here distance, otherwise we can take any other values. So how should we take? So here we are following the Pythagorean proof. Here it is called hypotenuse, and it is the height we can say, or base also we can say, or side also we can say. This is the side we can say, and this is also a side or base of the triangle also we can see. How we are having that Pythagorean proof? So here we are taking OQ square is equal to OP square plus PQ square we are having. So this is the Pythagorean proof we are having, and the tangent should be, here we are having PQ square is equal to OQ square minus OP square, and PQ is equal to square root of OQ square minus OP square. This is the way we can identify the length of the tangent by using the Pythagorean proof.